So, a very good afternoon to all of you. Today, our team is here to present our project titled Early Prediction of Chronic Kidney Disease Using Machine Learning. So, let's talk a little bit about what is machine learning. Machine learning is a mathematical representation or usage of algorithms to train data sets and make predictions. So here we are going to take some of the medical data of the user and diagnose whether the user has got chronic kidney disease or not. So here is our team ID, and our team consists of three people named Karan Sehgal, Karan Vyas, and Parth Gupta. So I'll be handling the data collection and data pre-processing stage of machine learning, while Parth will be handling model testing, model tuning, hypermetric tuning, and Karan Vyas will be handling the project deployment part on Flask. So let's start. Let me take you to my project. So as you can see, we are importing required libraries such as pandas, numpy, matplotlib. So what does panda do? Panda is a library in powerful and widely used open source data analysis and manipulation library in Python. We can form data structures and functions needed to work with structured data seamlessly. Here I have used the word structured because we have got table data. So, and NumPy is for mathematical analysis, while Matplotlib and C1 are for data visualization. So here we import our libraries, and then we read our data using read CSV function as we have got our file in the CSV format. So let's quickly have a look at the CSV file. So this is what our CSV file looks like with like columns having medical importance such as blood pressure, specific gravity of urine, albumin in blood, sugar levels, RBCs, red blood cells, pus cells, like blood glucose random, hemoglobin, hypertension. So these are the features which we train our data on so that we get this classification. So that this is our target variable, which we have to predict. So let's go back to our like the file. So data head function quickly gives us the top five columns, top five rows of all the columns. It is just usually used to have a quick peek at the data. Data shape represents that there are 400 rows of 26 columns each. Here are the data types. Here are the data columns. Data.describe function is used to provide statistical analysis of each of the column, where we can see the count, mean, standard deviation, min, max. So is null dot sum function is used to find whether there are the null values and how many null values are there. So let's talk about pre-processing step. So data pre-processing is a very crucial step in the machine learning pipeline as a whole that involves transferring raw data into a clean and usable format before feeding into the machine learning model. The goal is to enhance the quality of data so that the data is not erroneous and which can actually improve the performance and efficiency of the model. So here are very key steps in the data processing model, which will include data cleaning, data transforming, data reduction, data splitting, which I will explain as I go on. So let's look at the RBC column. So RBC column is, let me have a look at RBC column. So the RBC column is good or bad. It is not a numerical value, right? See, normal, normal, abnormal. So we cannot feed this directly into our data model. So what do? We encode it. So we encode it using a technique called label encoding. Now, what do we mean by label encoding? Label encoding is a technique used in data processing to convert categorical data into numerical format for machine learning model to use it. Now, what do you mean by categorical data? Something like good, bad, or low, medium, high, which can have both as basis of the feature. So For such intrinsic data such as low, medium, high, good, bad, we often use we often use label encoding, and label encoding reduces dimensionality and provides efficiency. So let's import this library, label encoding function. I made the L1, and then I fit transform it on data RBC. And now we can see the RBC value is 0, 1, and 2. But how it is 0, 1, and 2? It should have gotten two normal and abnormal, so 0, 1 only, but it is showing two, which means we have null values in the data, which is by which it is assigned null values as two. So we are filling our null values with mean of the column in the age. See, now we don't have any null values. So same way for BP, same way for SG, same way for AL. So now what we are doing, we are filling our data null values. Now, why do we have to fill null values? We have to handle missing values because we cannot feed the model incomplete values. So this is very basic steps, filling NA and then transforming it. We are transforming data into suitable format of structure so that our model has an easier time processing. Now here we are dropping single column like BA because it has no significance whatsoever in diagnosing chronic kidney diseases. And we are dropping ID column because I, identifier for each entry does not help us in identifying whether the person has chronic kidney disease or not. So this is what data pre-processing looks like, where we go on each column one by one and add to it. Like PCV column here had some errors, so we fixed it. We've converted all the column to numeric because the mean works on numerical values. It cannot process string values. So we are now reaching the end of our data sets. We have processed nearly 25 to 26 columns. And see, now we have reached the classification variable, which is our target variable, which we have to predict. So CKD is 250 and not CKD is 150. So here are no null values. So we now label encode our classification so that CKD is 0 and not CKD is 1. We drop our column and now this is the final set of columns which we will use. This is our target variable y. Now, why do we split our data? Why do we split our data for model testing? So, dividing the data set into training, validation, and test sets allows us to evaluate the performance of the machine learning model. Fine. We train the data on training set and then we predict the values and then we compare it to the test set. Fine. And then we standards use क्या कहते हैं इसे? Normalize it. Normalize the data set. And then we split the data into test and train sets using train test split function from skit model dot selection. So see, we have divided this into a ratio of 70 to 30. So we have a X train 280 and XSS 120. So this till here we have cleaned our data and now it is ready to be fed into the model. So the next step of the part will be handled with by my roommate.
So good afternoon, everyone. My name is Parth, and I will be continuing from the model training part. So, my teammate before me just cleaned the data and split it into two, X-train and Y-train. so that we can test it accordingly. So first we will go with the model training part. So we will be looking at three different kind of models so that we can choose which is the best between them. So first we will go with decision tree classifier. Decision tree classifier is a nonlinear model that splits the data into subsets based on feature values. In this, the feature values will be like different type of parameters related to health like sugar, albumin, and BP, etc. So now we will run this cell. So we have imported this from sklearn.tree library, and and this is a inbuilt function in Python, and we just need to import it into a variable, in which in this case is df, and then we will fit the data. So we have fitted in, as you can see, this is a model. So now we will be testing the data on the xtest file. Okay. So this is the values that have been predicted by the model, and these are the values that were already inside our data set. So now we will, to see the accuracy of our data, we will import the accuracy score, confusion matrix, and etc. The all the these parameters from sklearn.metrics library, and now we will test them. So as you can see, the accuracy of this model decision tree is coming as 1. And the confusion matrix is also showing that there are no false values. So this may be because the data model is overfit or something. We will make the decision based after we tune the model. So coming now, we will see the classification report. As you can see, this is a very good classification report, but we will make our decision after after model tuning. Now we will go with logistic regression. Logistic regression is used in for binary classification, which according to me should be the best case scenario for our model, since we are also classifying whether a person has chronic kidney disease or doesn't have chronic kidney disease. So we do the same step in this also. These are our values that are predicted by the logistic regression. So our accuracy using logistic regression has come as 94.16%. Uh, this is our confusion matrix. As you can see, three false positive and four false negative values have been, we can see that has are coming in this. So this is the classification report. Still, we will make our decision after the model tuning phase. So we are again splitting the data. And now we will use k-neighbors classifier. K neighbors means k nearest neighbors, and it is a simple instance-based learning algorithm that assigns the class of a test instance based on the majority class among its k nearest neighbors in the training set. So we will again do the same things. A model is created. Now we will predict. These are the values that are being predicted by KNN. Uh, it has a low accuracy of 67.5%. Here is the classification report. Here is a confusion matrix. Now we will go towards the model tuning phase. These are the three models. Now we will go towards the model tuning phase. Model tuning here refers to the process of optimizing the hyperparameters of the model to improve its performance. We are using grid search with cross validation to tune the hyperparameters of the model. As you can see here, we have imported the grid search from the sklearn.model selection library, and we will be using that inbuilt function. And you can see that our penalties, these are the things. As you can see, after tuning the model, our accuracy for logistic regression has become 98.33%. Accuracy for decision tree has become 95%, and accuracy for KNN classifier has become 78.75%. So as you can see, the best accuracy is for logistic regression. So that is the model that we will be using in our project. So here we are testing the class. These are the classification reports, and we are testing individually. Okay, so now that we have chosen a model, now we will be saving the model into a file. So here we will be using the pickle library of Python. It is a built-in library that we can use to save our model. Okay, so we will be importing pickle, and this is like with the inbuilt function pickle.dump in the pickle library, we will be saving our model into the ckd1.pkl file. So now, since we have saved the model, now the last part of our project is to deploy the model using Flask in HTML, and that will be explained by my teammate Karan Vyas. Thank you.
Good afternoon everyone. I am Karan Vyas and I will explain you the Flask code for this project. In our repo, inside the project executable file, we have the Flask code. First, this is our Python file app.py. Let me show you by running this file. The command will be python app.py. It will take some time, yeah. And this is the link. This is our home page. Like this app.route slash for the function home, we have HTML file home.html, our first page, index page, and by clicking on start prediction, we went to the route slash prediction. And now, so let me explain you the code first. This is all the libraries that we imported for this project, and this is our model file ckd1.pickle, which my friend Parth already explained. And this function is used to for transforming the strings to numbers. In the model, we took these strings as a number, yes, poor, normal, present, are considered as 1, and no, good, abnormal, not present are treated as 0. That's why I converted these things. These values, when they come from the form, will be transformed into 1 and 0. Inside the prediction router, we are rendering a page index new.html, which is a form. Now let me fill the values inside this form. Let's consider age as 72, BP 60. After that, the specific gravity 1.02, abnormal 0, then sugar level 0, red blood count normal, per cell not present, PC normal, BGR as 1.09, PU 26, it should be 1.09, not 1.09. Okay, now our SA is 0.9, 150, 4.9 is our potassium, After that, hemo is 15. PVC is, let's assume 52. Blood count is 10,500. And red blood count is 5.5. After that, hypertension, no. This is also no. CAD, no. Appetite should be good. PE, no. And anemia is no. Now when I will submit, it is saying, it showed us the result that you don't have a chronic disease. Now let me show how the code works for these things. Inside the app.py, we have the predict route. Okay, its method is post, and inside this route we are calling a function predict function, and this line took the input from the form and transforms the input into strings or integer, and these integers are converted into an array of integers and are passed inside this model. Inside the model.predict input feature. This then our model will predict the answer whether it is a chronic disease, whether the patient have chronic disease or not, and it will return the output at 1 or 0. So if it gives 1, then yes, you have a chronic disease, or if it doesn't give 0, if it gives 0, then you don't have a chronic disease. Then we store the string into a variable predict test and pass the variable into the result.html file. So this is our result.html file, and